Hello, everyone. Welcome to AI-driven cloud security in quantum threads. I am Shilpi Mittal, working in a food manufacturing organization. With me, we have Ankit Gupta, who works in a financial organization. This presentation is part of Cyber Back to School series. Today's session explores how artificial intelligence can enhance cloud security as we transition into the quantum computing era. We will focus on Microsoft's tools and strategies to build resilient, attack tolerant, governable policy compliant, and future ready quantum safe cloud solutions. As technical professionals, you can expect concrete insights and Microsoft focused tool overviews. By the end, you will understand emerging threats for AI and quantum and how to leverage Microsoft security stack Azure, Defender, Sentinel, Purview, etc. to stay ahead. Let's dive in. We will start with current threat landscape, focusing on how AI and impending quantum advances are reshaping security challenges. Next, we will explore AI-driven cloud security, how Microsoft's AI capabilities like Microsoft Sentinel, SIM, and Security Copilot empower defenders. Then we will explain quantum threats to cryptography. By future quantum computers could crack today's encryption and what that means for cloud security. Building on that, we will discuss resilient cloud architects and how to achieve them with Microsoft tools for zero trust principle to Azure's DDoS protection and backup solutions. We will cover governance and compliance in cloud using tools like Microsoft Purview for data governance and Entra ID for identity governance. Critical for governable cloud, we will also specifically address hybrid and multi-cloud security using Azure Arc and Defender to extend security across on-premises and other clouds. Finally, in future-ready strategies, we will pivot to post-quantum cryptography and Microsoft's initiatives, the Quantum Safe Program, EQC in Windows, etc., to ensure our cloud solutions remain secure in quantum era. We will wrap up with concrete action steps you can start now to become quantum ready and leverage AI in security. Let's begin with the threat landscape. The threat landscape is escalating on multiple fronts. Microsoft's latest data shows an astronomical volume of attacks, 84 trillion security signals analyzed per day, with 7,000 password attacks every second. Sheer scale makes manual defense impossible. It underscores the need of AI and to help defend at machine speed. At the same time, attackers are weaponizing AI, for example, using generative AI to craft phishing or malware that can evade traditional defenses. In a report of 2025, three-quarters of German companies said Gen AI's rapid advancement is now a top security risk. This shows AI is a double-edged sword. It can empower us, but also our adversaries. Looking slightly further out, quantum computing is no longer science fiction on the distant horizon. It's a coming reality. Governments, US, EU, China, and others, and companies like Microsoft are investing billions in quantum tech. Why does this matter for security? Because a sufficiently powerful quantum computer could break the cryptography, like RSA, Diffie-Hellman, elliptic curve, that underpins nearly all cloud data security. Imagine the impact if encryption fails. It's a massive threat to confidentiality. That this is just not an hype. World's leaders are taking notes. The UK's economic plan highlighting AI, security, and quantum. Singapore's recent cybersecurity summit, thousands of leaders focused on threats from quantum and AI. In short, AI and quantum threats are global concerns now. The imperative for us is to use AI driven defenses to handle today's volume and sophistications of attacks and become quantum ready to safeguard our cloud environments for the future. Now let's switch to quantum threat and why it's such a big deal for cloud security. In essence, quantum computing poses a threat to undermine the cryptographic foundation of the cloud. Practically all of our cloud security relies on encryption. When you connect to Azure or AWS, you are using TLS encryption, often with an RSA or elliptic curve key exchange. When you store data, you might encrypt it with keys protected by an asymmetric algorithm. Even admin authentication uses protocols like OAuth or SAML, which relies on public key cryptography. These algorithms like RSA, Diffie-Hellman, ECDSA are secure only because today's computer cannot feasibly solve the mathematical problem behind them, factoring huge numbers or resolving discrete algorithms. Quantum computer changed the equation. In the 1990s, mathematician Peter Shor developed Shor's algorithm, which proved that a quantum computer, if large enough, can factor integers and break those crypto problems exponentially faster than a classical computer could. In theory, RSA 2048, which would take billion of years to brute force classically, could be cracked by a quantum computer with a few thousand stable qubits in maybe hours or days. This is what we mean by a CRQC, a cryptographically relevant quantum computer. How close are we to that? It's an open question. Some experts suggest that it may take 10 to 15 years, while others estimate 20 years or more. And some optimists believe it could be a few years. It's uncertain. What we can do or know is that process is ongoing. For example, just last year, Microsoft's research achieved entangling 24 logical qubit, moving towards stable, scalable quantum computing. IBM, Google, and others are frequently hitting new milestones. We even saw a claim by Chinese researchers using a specialized quantum machine, a D-Wave, to break a particular encryption instance. Not RSA yet, but it shows that trajectory capability. Now, even if the Q day when a quantum computer can break encryption in 10 plus years away, there is a critical immediate threat. Harvest now, decrypt later. Adversaries, especially national states, are recording encrypted traffic today. For instance, they might scoop up years of your company's VPN traffic or cloud data transfer and store it. They cannot read it now, but as soon as they have quantum decryption capability, they will go back and decrypt all that historical data. Think about sensitive personal data, intellectual property, or government secrets that are meant to stay confidential for decades. Those are at risk for exposure retroactively if we do not move to quantum safe encryption in time. This is why intelligence agencies and cybersecurity pros are already sounding the alarm. In short, quantum computing poses a systematic risk to cloud security. Without post quantum cryptography measures, which we will discuss soon, the confidentiality and integrity of data in the cloud could be broken entirely. Our secure internet connection, encrypted database, blockchain system, and digital signature all would be vulnerable. The industry and government recognize this, which is why you will hear terms like Y2Q, years of quantum planning. We need to prepare now so that our cloud solutions remain secure when quantum breakthrough arrives. Let's talk about how AI is super changing cloud security, especially through Microsoft solutions. In a modern security operations center, we have a process an overwhelming amount of data far beyond human capacity. Microsoft Sentinel, the SIM for Azure and beyond, was built with this in mind. It's cloud native and AI driven. Sentinel uses machine learning models to perform tasks such as behavior analytics, learning with normal user behavior looks like, and then flagging unusual deviation that might indicate a breach. It also has built-in SOAR capability, automation and response, and integrates threat intel fields. In short, it leverages AI not just to detect threat, but also automate the routining task of handling them. Taking it a step further, Microsoft introduced Security Copilot, which is basically GPT-4 for cybersecurity. Think of it as a highly trained security analyst that's available 24 by 7. You can ask security copilot questions about an incident which happened overnight on this server and what went wrong on that server. And it will summarize the incident, pull in relevant data, even write queries to dig deeper. It's like having a junior analyst who learn from global data. This helps human analysts triage and investigate much faster. In 2024, uh, 25, 2025, Microsoft went even further by adding autonomous security copilot uh, agents. These are specialized AI routines that can actually take actions in specific domains. For example, phishing triage agent in Microsoft Defender will automatically review incoming phishing alert, discuss real threats from false alarm, and explain its reasoning to the admin. There is an insider risk agent in Purview to prioritize insider threat alert, a conditional access optimization agent in Entra ID that find gap in your identity policy and suggest one-click fixes and more. Essentially, these AI agents operate autonomously under your oversight, handling high volume tasks. They adhere to Microsoft's zero trust framework, meaning they assume breach, verify explicitly, and have least privilege, so they can act carefully and securely. The result of using AI in security are notable. Organizations using Microsoft's AI capabilities have seen significantly improvements. For instance, an independent study found 97% fewer false positive alerts, lesser noise, and much faster breach detection when using Azure Sentinels AI compared to traditional tools. The bottom line, AI enable us to find the needle in the hay of stack and response before attacker can cause severe damage. With tools like Sentinel, Defender for Cloud, which use ML to flag misconfigurations and threat in Azure, AWS, GCP, Entra ID Protect, which protection, which use AI to detect compromised account, and the new security co-pilot agent. Microsoft is infusing AI across the board to help us defend cloud environment at machine speed. Preparing for quantum threat is a bit like preparing for a coming storm. We know it's one or it's on the horizon. We are not sure exactly when landfall happen, but we have a forecast that it will happen in that not too distant future. So why do we need to start now in 2025? Because the migration to quantum safe cryptography will be one of the most significant upgrades in IT history, possibly bigger than the Y2K prepare or the SHA-1 to SHA-2 migration. Think about everywhere we use cryptography. It's not just websites, it's embedded in applications, IoT devices, databases, storage systems, code signing, authentication tokens everywhere. We cannot flip a switch overnight. NIST, National Institute of Standards and Technology, has been running a multi-year competition to choose new quantum, post-quantum cryptography algorithm. And they announced the first winner. Three schemes have been standardized. For example, Crystal Kyber for key encapsulation and Crystal's Dilithium for digital signatures. These algorithms are designed to resist known quantum attacks. NIST is finalizing standards. Just last year, they published draft standard for these PQC algorithm. A fourth algorithm, probably a signature scheme like Falcon and Spenic Plus, is on the way. However, standardization is just step one. We need to implement these changes in both software and hardware, updating protocols such as TLS, IPsec, and SSH, and deploy them across all systems. Conversative estimates says that full transition could take 10 to 15 years. That's why even if we think the first quantum computer capable of breaking RSA comes in 2035, just as example, we truly have to begin now to be ready then. Governments are not waiting. The US has mandated the federal agencies initiate the process. There are OMB, Office of Management and Budget, memoranda, and NSA guidelines, which with a deadline of around 2035 for implementing quantum safe system. Microsoft, as a major tech provider, is aligning with those. In fact, Microsoft internal goal, as outlined in its quantum safe program, is to have its products and services transited by 2033, a couple of years ahead the original deadline. So if you are a customer, you can expect Azure, Windows, and Microsoft 365 to support PQC well before that. However, as enterprises, you also need to be prepared to adapt these new crypto standards. One of the things to do to establish crypto agility in your environment, that means ensuring you know what cryptography you are using and where. Microsoft undertook these exercises conducting an enterprise-wide inventory of cryptographic usage. Many companies realize they have hard-coded algorithms or outdated libraries that will be difficult to update. You want to refactor systems so that swapping an algorithm, say from RSA to Kybert, is not like pulling teeth. Use abstraction layer, utilize managed libraries, and avoid embedding algorithms directly into your protocols without flexibility. A quick point, the quantum threat primarily affect asymmetric cryptography. Things like RSA, Diffie-Hellman, key exchange, ECC, symmetric cipher like AES 256, and secure hash function like SHA-256 are not easily broken by quantum. Governors, Grover's algorithm, the quantum algorithm for searching, can at most provide quadric speed up, which means that doubling key length can mitigate this. So AES 256, for instance, is still considered as safe. Quantum would reduce its 256-bit strength to 128-bit, which is still okay. This is why Microsoft and others recommend prioritizing where you need to change crypto. Prioritizing asymmetric crypto first, update your TLS, your public key infrastructure, etc. Consider using hybrid encryption, combining classical and PQC as an intermediate step until it is fully standardized. In short, we start now because it's a long journey. The standards are becoming ready. Early adoption is starting. If you don't start assessing and planning, you could find your organization dangerously behind when quantum hacking capabilities emerge. Now I will hand over to my co-speaker Ankit to walk you through the resilience in the cloud solution.
Thank you, Shilpi. So resilience in cloud security means that when bad things happen, whether it's a cyber attack, component failure, or even a future quantum driven incident, your systems can withstand and recover with minimal damage. Let's talk principles first. First and foremost is a zero trust architecture, as you may have heard about it from like the last 5 years. This has been a big buzzword, but it's crucial for resilience. Zero trust says, assume the bad guys are already inside your network. Design with that in mind. That means no implicit trust based on network location or a single credential. We can enforce least privileges on everything. Users, app, even services should only have the minimal access they need. So in practice, using Entra ID with conditional access policies, applying just-in-time access for admins via privilege identity management, and segmenting networks via NSGs or micro-segmentation, these all can help. The idea is to prevent an initial breach from laterally expanding. If a hacker phishes one user, zero trust design help ensures that it doesn't grant access to the crown jewels automatically. This architecture combined with MFA and strong identity controls makes your cloud much more breach resilient. Next is redundancy and failover. The cloud provides us with numerous tools. we should utilize multiple availability zones or regions for critical workload. For instance, if you have an app in Azure, deploy it into areas with traffic manager or front door failover. That way, even if one region goes down, the service stays up. Also, keep resilient data storage in using the geo redundant storage and regular backups stored separately. For example, Azure backup is an isolated vault, ideally immutable. Ransomware attacks often try to wipe out online backups. Having offline or immutable backups ensure you can recover. The goal is basically to eliminate the single point of failure. And the next is the another aspect is the rapid detection and response. No system is 100% prevention proof. So resilience means quickly detecting an issue and mitigating it before it escalates. That's where tools like Microsoft Sentinel, SIEM, and Defender XDR come in. They provide continuous monitoring across your environment and advanced threat detection. For example, suppose an attacker gains access and starts exfiltrating data. In that case, you want to detect this via anomaly detection in Sentinel or an alert from Defender for Cloud that is VM is behaving unusually. Then you need an incident response plan such as automated playbooks that can isolate the VM or disable the user account immediately. The faster you can detect and respond, the less impact. Mean time to respond is a key metric here, and AI is now helping to reduce that. We also need to test our resilience. This is where chaos engineering come in. Microsoft offers Azure Chaos Studio, which allows you to intentionally inject failure faults, like simulating an Azure region outage, a VM crash, or even a secret expiring to see how your system responds. This proactive testing identifies weakness before they occur in real incidents. On the security side, conducting exercises such as red team exercises or breach simulations is valuable. Essentially, practice failures and attacks in a controlled manner to enhance system and team readiness. Finally, cryptographic resilience is an often overlooked piece. This means two things. You use strong crypto and protect your keys well today. Store keys in hardware security modules, example Azure Key Vault with HSM, or use Azure Disk Encryption and enforce TLS 1.3, etc. So that even if someone grabs data without keys, that get nothing, they get nothing. Be ready to swap algorithms, which is crypto agility, so that if tomorrow a weakness is found in any algorithm, quantum or otherwise, you can promptly shift to a new one. We have seen this happen with SHA-1, where everyone had to move to SHA-2, and it will likely happen again. Resilience is a broad topic, but these principles form a layered defense and recovery strategy. Now I will map you with some principles of specific Microsoft's tools and services that you can use. Azure DDoS protection downtime often isn't because of a hack, but because of a blunt force attack like a distributed denial of service, DDoS. So Microsoft Cloud has a built-in DDoS defenses at the network edge. If you enroll in Azure DDoS protection standard or the new premium tier, your public endpoints are guarded by Azure's detection systems. So when a flood of traffic comes, say an example like a million packets per second trying to knock you offline, Azure will scrub that traffic automatically. Here's a fun fact. Azure routinely mitigates some of the largest DDoS attacks on record, multiple terabits per second, transparently. So for you, this means higher availability, your service stays up with Azure soaks up the attack. So if you have a critical internet facing app, enabling Azure DDoS protection is a no-brainer for resilience. Azure Backup and Azure Site Recovery, these are your safety nets. Azure Backup can take snapshots, backup of VMs, databases, and files, etc. You can store them in backup vaults with immutability, meaning even an admin can't easily delete them for a period, which protects against ransomware trying to wipe backups. If ransomware or accidental deletion hits your primary data, you can restore from backup. Azure Site Recovery is primarily focused on continuity. It replicates your VMs or on-premise servers to Azure or to another region. If your main site goes down, ASR lets your failover to the secondary location quickly. For example, if you're running an app in East US region, ASR could continuously replicate it to the West US. Azure Chaos Studio, I mentioned it in the principles. It's worth reiterating as a tool. Chaos Studio is basically resilience as a service. Microsoft has a library of faults you can inject, shut down a VM randomly, simulate an entire availability zone outage, introduce 500 millisecond latency on the network, even expire a secret or certificate to see how your app behaves. You can run these experiments safely against, for example, the test instances or during a maintenance window to make sure your system handles failure gracefully. Using the same chaos tools Microsoft's own engineers use can give you confidence in your application's robustness. If something breaks during your chaos test, that's a good thing you found a weakness or fix before it hits in production. Then comes the Microsoft Defender for Cloud. This tool is often seen as a security scanner, but it's also a posture management tool that improves resilience. It continuously evaluates your environmental configuration. For example, if it will tell you if you have a VMs not backed up, or if your web app is missing a web application firewall, or if you only deployed in one availability zone. It then provides recommendations along with a secure score that guide you in hardening or making your deployment more robust. Basically, it helps you follow Azure well architected best practices for reliability and security. By following Defender for Cloud's recommendation, you often inherently improve your resilience. Then comes the last, which is Azure Monitor and Autoscale. These might seem like a basic cloud features, but leveraging them is crucial. Azure Monitor can alert you to issues like CPU spikes or memory leaks before they cause a crash, so you can respond. Maybe trigger an automation to cycle a role. Auto scaling ensures that if your service suddenly experiences a traffic spike, perhaps due to a legitimate load or an attack, Azure can add more instances to handle it rather than your service going down. Self-healing and scaling logic, like using Azure VM scale sets, AKS cluster autoscaler, etc., means your system adapt to stress without manual intervention, which is key to resilience. So in summary, Microsoft's cloud services provide a suite of tools to help you prepare for it, absorb and recover from disruptive events, whether those are attacks from or just an unexpected failure. Using these tools in with good design helps you a strong resilience posture. We have talked about resilience. Let's talk about governance, essentially how to keep your cloud environment under control and compliant as it grows. Governable cloud is one where you don't have wild west IT, but rather you have guardrails and visibility such that security and compliance requirements are continuously met. One big challenge with the cloud is how easy it is to create resources. Any developer or admin with a credit card or with some permissions in your tenant can deploy a VM, a database, etc. in minutes. Without governance, you might end up with shadow IT resources that IT security doesn't even know about, perhaps running sensitive workloads without proper controls, or even within sanctioned IT, you might have dozens of subscriptions and teams deploying things in different ways. That can lead to misconfigurations like someone forgetting to turn on encryption on a storage bucket or exposing a database to the internet by mistake. So governance is about enforcing consistency. Here is how we do things in our cloud. Regulatory compliance is a key driver. If you are a regulated industry, you likely need to demonstrate to auditors that your cloud's setup meets specific controls, such as those related to privacy, financial data, or health data. Cloud providers like Azure offer compliance certifications for their platform, but ensuring compliance when using the clouds is ultimately your responsibility. Governance gives you the central knobs to enforce these rules. Data governance is about knowing your data. This is huge. Many breaches happen simply because an organization didn't realize what data they had and where. In a cloud environment, data can proliferate in databases, data lakes, SaaS apps, etc. A governable solution has a way to classify and label data and then apply policies accordingly. Without data classification and DLP, which is data loss prevention, users might accidentally put sensitive data in an insecure location and share it improperly. Then we have identity and access governance. Cloud identity is the control plane for access to everything. Good governance means regularly reviewing who has access to data. To this means implementing processes like access reviews, attestations, and using privilege identity management so that admin roles are time bound. Um, of course, no one should have a permanent global admin. They activate only when needed. This also ensures integration with HR so that when someone leaves, their account is disabled. No orphan accounts lingering. And then there is operational governance using cloud native guardrails. Azure has Azure policy, a fantastic tool for enforcing rules. For example, you can have a policy no storage account should allow blob data to be publicly accessible, or all SQL databases must have transparent data encryption enabled, or only these regions can be used for deployments. If someone tries to violate those, Azure policy can deny it or at least flag it. Misconfigurations are a leading cause of cloud breaches, like databases left open or keys embedded in code. Governance tools help identify and prevent these misconfigurations systematically. They make your cloud environment predictable and compliant. Many of us operate in a hybrid work. We have some infrastructure on premises, maybe legacy systems or data that must stay on site. We use Azure for some workloads, maybe AWS or Google Cloud for others. Multi-cloud by design or due to acquisitions or developers' preferences. This reality can complicate security because each environment has its own tools and quirks. The goal is for a security team is to have consistent security policy and visibility across all these environments. We don't want a situation where our cloud stuff is well secured, but our on-premise AD is a weakling, or where Azure is locked down, but an AWS S3 bucket is open due to separate process. Microsoft's strategy to address hybrid is centered on Azure Arc. Azure Arc is essentially an extension of Azure management to any infrastructure. When you Arc enable a server, whether a physical on-premise server or a VMs in AWS, that machine gets your resource ID in Azure. It shows up in the Azure portal and you can manage it similarly to an Azure VM. More importantly, you can apply Azure policies and security services to it. For example, if you have a SQL server running on premise, you connect it with Arc. Now you can apply the same policy that ensures transparent data encryption is on as you would for Azure SQL database. You can install Defender for Cloud Agent on it and get it assessed for vulnerabilities and monitored for threats just like an Azure workload. Essentially, Arc breaks down these silos. It brings your hybrid resources under the umbrella of Azure security and governance. For multi-cloud, Microsoft Defender for Cloud, which is CSPM and a workload protection platform, supports AWS and GCP natively. You can connect your AWS account in GCP projects, and Defender will pull in their configurations and evaluate them. In one unified dashboard, you will see, for instance, that you have 5 encrypted storage buckets in AWS and maybe some configured security groups right next to similar findings it reports for your Azure resources. For identities, a common best practice is to use one identity provider as much as possible. Entra ID can integrate with on-premise AD via federation or sync. That covers the on-prem users, but you can also integrate Entra ID with AWS and GCP. For example, use Entra ID as an SAML IDP for AWS IAM Identity Center, meaning your Entra ID accounts with MFA conditional access are what you use to log into the AWS console. This way, you have consistent enforcement of things like MFA and conditional access policies across environments. It also means if somebody leaves the company, disabling their Entra ID account cuts access to all connected resources instead of having to disable in multiple places. Regarding compliance in a hybrid setup, it's not enough to just secure Azure and ignore on-premise. If you have a compliance requirement, an auditor will look at everything. So you want to extend your governance to on-premise and other clouds too. Using Azure Arc, you can apply Azure policies on VMs in your data center. Microsoft Purview can connect to an on-premise data source to classify and govern that data alongside cloud data. And Sentinel can aggregate audit logs from on-premise systems. So when you generate a compliance report or just review your security posture, you are seeing a holistic view. The key takeaway, Microsoft provides tools to make hybrid and multi-cloud security feel like a unified effort rather than separate silos. Azure Arc is fundamental in this, acting as that bridge. So you can leverage your Azure skills and tools to also manage security on-premise and in other clouds, which is both efficient and reduces the chance that something falls during the cracks in an unmonitored corner of your infrastructure. Let's focus on being future ready with our cryptography, specifically adopting post-quantum cryptography or PQC. PQC algorithms are essentially our armored walls for the quantum age. They rely on mathematical problems that we believe both classical and quantum computers cannot crack, or at least not easily. The most mature PQC algorithms that have emerged using lattice-based cryptography, hash-based signatures, and multivariate equations. For example, Crystal's Kyber is a lattice-based encryption mechanism that is now becoming the industry standard for replacing RSA key exchange. Crystal's Dilithium is a lattice-based signature scheme to replace traditional RSA or ECDSA signatures. Falcon is another signature scheme, and Sphinx Plus is a hash-based signature. The key point is that these do not succumb to Shor's algorithm or other known quantum attacks. NIST selection process was extremely rigorous. They chose these algorithms for both security and performance, ensuring they run efficiently on today's classical hardware. There are trade-offs, of course. For example, a Kyber public key is around 800 bytes compared to only 256 bytes for an RSA 2048 key. Signatures are also larger and require more computation, but engineers are already optimizing these challenges. Now let's talk about the transition. We cannot flip everything to PQC overnight. That's why interim hybrid cryptography is so important. In hybrid mode, you use two algorithms for the same task. For example, in a TLS 1.3 handshake, you could generate two sets of keys, one via classical ECDHE or one via Kuiper. The final session key is derived from both. This way, even in an attacker can break in one algorithm, the communication stays secure as long as the other holds strong. The IETF is currently developing standards for hybrid key exchange, and Microsoft has already contributed to enabling hybrid TLS in OpenSSL. We will likely see browsers and servers supporting dual algorithm handshakes in the next few years as a transition measure. Microsoft is actively integrating PQC. The core of Microsoft cryptography in Windows and Azure is SymCrypt. As of early 2025, SymCrypt has added MLKEM and MLDSA. MLKEM is essentially Kyber, and MLDSA is similar to Dilithium for signatures. These algorithms have already been rolled out to Windows 11 Insider builds. That means if you are in the Insider program, you can test PQC today through the Windows Crypto API and certificate functions. Microsoft has also released a PQC-enabled OpenSSL for Linux systems so that Linux server can talk PQC with Windows Server. Current Windows build now support these PQC algorithms to help defend against the harvest now decrypt later threat. MLDSA is being positioned as the go-to standard for digital signatures in a quantum safe world. NIST selections are now being adopted into protocols like TLS, SSH, and IPsec. This means industry-wide adoption is already underway. On Microsoft roadmap, as you can see on the screen, the Quantum Safe program began with internal research between 2014 and 2022, followed by an official program launch in 2023. The plan is for early adoption of PQC by 2029 and full transition by 2033, which beats the US government's 2035 deadline. This transition covers everything from Entra ID for authentication to Azure Key Vault for secure key storage to Windows servers and Azure SQL, Azure SSL and TLS endpoints, and more. Azure has even experimented with PQC-enabled VPN tunnels between data centers as early as 2024, and Microsoft has joined industry coalitions such as the Open Quantum Safe project. So what does this mean for organizations? The message is clear. Start piloting PQC now. Watch for when your vendors, including Microsoft, introduce PQC support and be ready to enable it. Internally, you could start by testing PQC-enabled TLS between a client and a server today using modern OpenSSL builds. Ensure your cryptographic libraries are always updated so that when Windows or .NET enables PQC, your applications can adopt it seamlessly. The transition is coming. Being future ready means not waiting until the last minute. Microsoft recognized early that becoming quantum safe is not just a flip of a switch, it's a strategic and long term journey. In 2023, under executive sponsorship, they established the Microsoft Quantum Safe Program, also known as QSP. The QSP is essentially an internal task force and framework that coordinates everything related to post quantum security across all of the Microsoft products and services. Charlie Bell, a Microsoft Security Executive Vice President, described the vision as unifying efforts and accelerating the transition for both Microsoft and its customers. The program set three priorities. First, make Microsoft itself quantum safe by updating all first party services, internal processes, and supply chain cryptography. Second, help customers and partners become quantum safe by providing tools, guidance, and products that ease the transition. Third, promote global standards and research for PQC and crypto agility. We have already discussed the technical work, such as the SimCrypt updates, but the QSP also involves high-level planning. For example, Microsoft conducts crypto inventories across all teams, then sets milestones so that by certain years, such as 2025 or 2027, each division has implemented PQC in its domain. Their overall timeline aligns with the strictest government deadlines, including CNSA 2.0, and aims to complete the transition by 2023. Sorry, 2033. For customers, Microsoft launched the Quantum Ready program. This initiative is designed to engage business leaders about quantum. A key part of its education, since only a small fraction of organizations feel prepared to assess quantum opportunities and risk. On the standard front, Microsoft is deeply involved. They are founding member of the Open Quantum Safe project, which provides open source libraries and tools for prototyping PQC integration. They also collaborated with NIST on example implementations of PQC. Microsoft has even co-developed an alternative PQC algorithm called FrodoCam, which is being considered by the ISO. Although NIST did not select FrodoCam, it shows Microsoft commitment to ensuring multiple options are researched and standardized. They are contributing to ISO standards This ensures that Microsoft solutions will not be proprietary one-off, but also adhere to global standards for interoperability and trust. There is also an hardware angle. In 2024, Microsoft announced Adams Bridge, an open source cryptographic accelerator design that is part of Open Compute Project's Calyptra 2.0. This is aimed at handling the heavier math of PQC efficiently, suggesting that the future Azure servers and even PCs may include built-in hardware for quantum resilient cryptography. To wrap up, Microsoft multifaceted approach combining internal programs, customer guidance, global standardization, and long-term R&D is designed so by the time PQC is truly needed everywhere, the Microsoft ecosystem will be ready. Let's conclude with actionable roadmap that you can follow to apply what we have discussed. First, supercharge your current security with AI by adopting the tools like Microsoft Sentinel. It's a low-hanging fruit that can dramatically improve your threat detection. Consider also using Microsoft Security Copilot to help your security team investigate and respond more quickly. Being an adopter of these AI tools will pay off in terms of efficiency and frankly in identifying things like legacy tools miss. Second, double down on zero trust and governance. If there are gaps, close them. Implement conditional access policies in Entra ID to enforce MFA, device compliance, location risk, and other relevant controls wherever feasible. Use privilege identity management, set up Azure policy to prevent bad configuration, and also ensure a purview is deployed, which can help you to classify your data and set up DLP policies. Third, integrate your hybrid multi-cloud assets. So if you have in on-premise servers that are not onboarded to Azure Arc, plan to onboard them. It's usually as simple as installing an agent. Fourth, prepare for quantum now. Task your security architects to conduct a crypto inventory, list all instances where you use RSA, ECC, etc. It could be VPN appliances, internally developed applications, or partner connections. Identify what libraries those systems using, and then follow the progress of library getting PQC support. Fifth, educate your teams. The tech landscape is evolving rapidly with the advent of AI and quantum computing. Make sure your teams aren't caught flat-footed. The Quantum Ready program, as we mentioned, could be valuable opportunity to engage leadership in creating company-wide quantum risk assessment. Basically, by taking these steps, you are incrementally building a cloud environment that is not only resilient to current threats and outages, but also primed to handle the next generation of threats from quantum computing. It's a journey, but you can start taking off these items one by one. Let's wrap up with the narrative of what we have covered and what you should walk away with. AI and quantum are two game changers in tech right now, and they are double-edged swords for security. Microsoft ecosystems gives us strong advantage in doing this. Um, One of the big advantage of using a suite of tools from one of the providers integration with all the existing on-premise as well as the cloud resources. You need to remember that the security is never set and forget. The threat landscape will continue to evolve. Who knows, maybe in a few years, we'll talk about defending AI models themselves from adversarial attacks or the next breakthrough in quantum algorithms. The point is to build a culture of continuous adaptation. So my call to action for you would be don't leave this for someday. Go back and assess where you stand. Are you using AI in your SOC or are you analyst drawing in alerts, droning in your alerts with legacy seams? Try out something like Security Copilot or at least the AI capabilities in Microsoft Sentinel New Incident View. Finally, I want to emphasize it's easy to view AI and quantum as purely threats, but they also hold promises. AI can actually make our systems safer, and quantum computing, while a threat to current encryption, will also enable new types of encryption and could revolutionize certain defenses. In the end, it's all about staying informed and proactive. If you do that, you won't get off guard. You will lead your organization through these changes confidently. Thank you for listening. I hope you found these insights useful and feel empowered to build cloud solutions that are resilient, well governed, and ready for whatever the future brings. These are some of the resources that you can refer to when required. This concludes our presentation for today. Please feel free to reach out to connect.